So I'm going to go through and explain how to do number 11. It's a limiting reactant problem again, but the only tricky part is that you actually have to write out the reaction. So here you've got iron 2 hydroxide. So to create iron 2 hydroxide, you need to cross Fe, which has a 2+ charge, which I tell you here, and hydroxide, which has a -1 charge. So when I cross my charges, I get Fe in parentheses OH2. That reacts with H3PO4, I give that to you. And so what you should notice is that this is a double replacement reaction. So my products are going to be Fe, which is a 2+ charge, and PO4, which has a 3- charge. So when I cross my charges, the 2 goes there, the 3 goes there, so I get Fe3, PO4, 2, and the PO4 is in parentheses. And then also notice that H and OH are going to combine. H has a +1 charge, OH has a -1 charge, so I end up getting HOH, which is the same thing as H2O. And then I just balance using coefficients, and that's it. Here, this is just a limiting reactant problem at this point, so I'm going to use this formula to solve it. I tell you, you have 3.20 grams of FeOH2 and 2.50 grams of H3PO4. So I want to know how many grams of Fe3PO42 iron phosphate both of these will produce. And so what I do, I first need to go from grams of iron oxide into moles of iron oxide, and I use the molar mass here. Then I go from moles of iron oxide to moles of iron phosphate using the 1 and the 3. Those are your coefficients. So the 3 is there, the 1 is that coefficient. And then I need to do one more step to go from moles of iron phosphate into grams of iron phosphate. Now this number here and this number here, those are your molar masses of FeOH2 and iron phosphate. And so I get 4.24 grams that are produced of your iron phosphate. You do the exact same thing for H3PO4. If I start with 2.50 grams of this, I first need to go into moles of that. So I put the 98 there, 98 grams, which is the molar mass of H3PO4. Then I get into moles of iron phosphate by putting that on top, and moles of H3PO4 here. And then I go from moles of iron phosphate into grams of iron phosphate. Again, this is the molar mass of iron phosphate, and 98 is the molar mass of H3PO4. So what I get when I do my math is 4.56 grams, and both of these are grams of iron phosphate. So what you should notice is that since only 4.24 grams of iron phosphate are produced for this one, you'll run out of iron hydroxide before you run out of H3PO4, because this can make more of your product. So only 4.24 grams of iron 3 phosphate can be produced. So that's your answer there. And if I asked you what your limiting reactant would be, it would be your iron hydroxide, because it can only make that much. That's a smaller amount. The last step is to find your percent yield. Now, percent yield is the actual divided by your theoretical. Remember, actual is what you actually get in the lab. So I either have to give it to you like I did here, or during the test you would have to go back into the lab and complete the lab, which obviously is not going to happen. So the 3.99 grams is your actual yield, which you put on top. Your theoretical is what you should have gotten, which is what you calculated here, your 4.24. This is how many grams of iron phosphate you should have produced. So you put that on bottom, multiply by 100, make sure to have 3 sig figs, and I get 94.1%, and that's it.